In this chapter, we are going to look at how to estimate population parameters. So, say this is the population, say x is the random variable, and with the mean mu and the sigma standard deviation. So, we want to estimate mu, sigma, or functions of those parameters. So, using this random sample. So the reason is it's a single sample. Right now we are looking at one population and one sample coming out of that. Okay. So later we will look into more populations with several samples. So once you have this, say this. So using this random sample, we are trying to estimate. Let us look into, in the beginning we are looking into this, and then later we will look into other things. So if you want to estimate mu, so you already know one good estimate is x bar. So there are two types of estimates we are going to look at. So one is known as a point estimate. In other words, it's a one value estimate. Say for example x bar. You pull your random sample, you figure out the x bar, and that is your estimate for the mu. Okay, so that's known as a point estimate, one value estimate. The other type of estimators, they are known as interval estimators. Also, later we say that they are confidence intervals. So when you say interval estimators, instead of reporting one value, we are going to report an interval. In most cases, pretty much is centered around that one value. So we are going to say that this mu value is going to be within from here to here. We don't say that it's exactly that value, but it's going to be from here to here, and later we will say that with this chance or something like that. Okay, so that is an interval estimators. So this is what we are going to especially look into in this chapter, interval estimators. So before I get into that, I need to introduce a couple of standard notations. So, you already know this z-curve. Says z-curve, the standard normal curve, normal with 0 and 1. So suppose you are looking at on the z-curve, leaving area to the right of this value. So in other words, this area is A. So we denote this value by ZA. So in other words, so if you are looking at, if you look at the Z table, to look at the point 0.025 to the right of that value, if you are trying to figure out this value, leaving 0.025 to the right, that value is going to be 1.96. Okay, from the Z curve. This is coming out of the Z curve. Please read the Z table. Okay, so that is going to be, so this area is 0.025. So in other words, if you are looking at point Z 0.05, so pretty much you are leaving 5% to the right. So 5% to the right, Z table value, from the Z table you see that that's going to land in exactly in the middle of two values, 1.64 and 1.65. So therefore I take the average, 1.645. So Z 0.05 is 1.645 and Z 0.025 is going to be 1.96. So in different words, what that means is this actually. From the Z curve, if you want to cover 9, you already know that the Z curve is symmetric around 0. If you want to cover 90% of the curve, okay, 90% of the curve, so in other words 5% to the right and 5% to the left. So in the middle, 90%. So if you want to cover the 90% of the curve, you need to look at within minus 1.645 all the way to up to 1.645. Okay, because that's a standard normal centered around 0 with a standard deviation 1. So if you want to cover 90%, 95% of the curve, 2.5% to the right and 2.5% to the left. So in the middle, 95%. So it's going to be, you need to look at within 1.96 standard deviations of the mean. Okay, so you may want to memorize these two values because we are going to frequently see these values all the time. So you don't want to look at your z table all the time. Okay, it's okay if you don't memorize it, but the thing is that then you have to read your z table every single time you run into that value. Okay, so it's a good idea to memorize this. Okay, those two values. So anyway, so in different, so this is for the z curve, mean 0 and standard deviation 1. So now what happened if you are looking at a normal curve with mean mu and the standard deviation sigma. Okay, so in other words, so if you are dealing with a normal curve with mean mu and the standard deviation sigma, so if you want to pretty much, if you are looking within 1.96 standard deviations of the mean, so I'm saying that within 1.96 standard deviations, okay? That. So here you convert into z, so this minus mu divided by sigma, this minus mu divided by sigma, that will give you the z, minus mu divided by sigma. So this part is minus 1.96, this part is 1.96. You already know that this is 0.95, okay? So within 1.96, 95% of the curve. All right. So in other words, from the normal curve, with any mean mu and the sigma, if you want to cover 95% of the curve, you need to look at within 1.96 standard deviations of the mean. Within 1.96 standard deviations, this many to the left and this many to the right. Okay? So that is if you want to cover 95% of the curve. And if you want to cover 90% of the curve, the same way you can see that the minute you replace this thing by 1.645, the other number I told you to kind of memorize, so you are going to see that 90%. Okay, so the idea is now, so from any normal curve, so if you want to cover 90% of the curve, you need to look for within 1.645 standard deviations of the mean. That will cover 90% of that curve. If you want to cover 95% of the curve, then you need to look at within 1.96 standard deviations of the mean. And also if you want any other value, suppose you want to cover only 80% or 85%, then you need to look at your z table and then figure out that value. Okay, so in different words, suppose now if you want to cover 1 minus alpha percent, alpha is a value in between 0 and 1. Okay, so in most cases later you will see that we are looking at very small values. Okay, so this is 0 and 1, but in general they are very close to the 0. Okay, so if you want to cover in other words, if you are looking in terms of 95%, then with this notation alpha equal 0.05. Okay, this with 95%. This goes with 95. So with 90%, that alpha goes with 0.1. Okay, so if you want to cover 1 minus alpha percent, 1 minus alpha probability, this is probability. If you want to cover that for this normal curve, all right, so centered around mu with a standard deviation sigma. So what you need is that from the z curve, so from the z curve you need to look at, from the z curve you want to cover 1 minus alpha right in here. The same way this works out. Okay, so this got to be alpha over 2 and here alpha over 2. So this is z curve, okay, centered around 0. That's why this is alpha over 2 and alpha over 2. So 1 minus alpha in the middle. So this our notation, according to our notation, this is z alpha over 2, the area to the right. And we know that the z curve is symmetric around 0. Therefore, the other the value on the other side got to be minus z alpha over 2. Alright, so that means if you look at the area, if you look at the area within within this many, mu minus z alpha over 2 sigma, the x curve, this is the x curve, all the way to mu plus z alpha over 2, this area is going to be exactly 1 minus alpha. Because the reason is that the minute you convert into z, this is going to go down to, see this mu z alpha over 2 sigma minus mu divided by sigma. Okay, so this x and the same thing over here. Okay, so this is going to be, so minus z alpha over 2, and this will turn into z, and the z alpha over 2, so this is going to be that. Okay, so in other words, so basically if you want 80% or something, later on you have to look at your z table and figure out that the table value. Okay, so anyway, this is what it is. So if you want to cover 1 minus alpha percent, I need to look at within that many standard deviations of the mean. Okay, alright, so let me stop here and get into the next video, because I don't want this thing to go over 15 minutes. Okay, alright, so I'm going to start right from the here next on the next video. Okay.